Sometimes kernel need to send some asynchronous notification to the foreground process. Why and when? Well, you just learned pipes. Suppose your process is trying to write into a pipe where there is no reader, or process is trying to read from an empty pipe, there is no writers. So these are kind of operations which will never succeed. Application will never know about that. So it is a kernel that is responsible, that has to take care that these are implemented properly, and that the illegal operations and the corresponding processes should go, not execute. Or suppose you have used some pointers and you're trying to access memory locations outside of the stack segment or the data segment. You are trying to access an illegal memory location through illegal pointer that is not pointing to the allocated memory. So there also application will never know. The kernel have to intervene, and the kernel have to see to it that these issues are resolved, or if could not be resolved, then the processes that are doing illegal operations should be terminated. So these are the asynchronous notifications that are sent to the foreground process by the kernel. Inside the kernel, the kernel components that are sending these signals are called terminal handlers. What is a foreground process here? Well, any process that will have all 0 and 2, standard input, standard output, and standard error, or any one of these three processes, file descriptors connected to the process, such a process is foreground process because we can interact with it. Signals could be sent only to the foreground processes. Okay. Signals are like software interrupts because they exhibit behavior something like software interrupts, but internally they are not implemented as software interrupts at all. Yes, Siddharth?
सर asynchronous का मतलब क्या है?
Asynchronous means it can come at random any time. Asynchronous means no two communicating parties has to be present at the same time. Like sending mails, you send mail, it is not important that the other person, the recipient, should also be logged in while you send the mail. But phone call is not synchronous. You can speak and transfer data only when the receiver is also connected. Asynchronous means out of time, can be present at different times, and the data could be sent at any time. So a signal is an event generated by the Unix or Linux system in response to some condition. Means something illegal has happened, the kernel is not going to tolerate it and have to intervene to stabilize the system. Okay. Now whenever the process receives a signal, the process has to respond. Another thing that comes to our mind is terminal handlers. What are terminal handlers? Well, the terminal handlers are kind of software component inside the kernel that is used to establish some kind of interaction between kernel components. Like kernel components, you have a process management, you have memory management, you have hardware interaction, you have interrupt handling. All these are kernel components, and the kernel components interact with each other through something called terminal handlers. These terminal handlers are responsible for all kind of communication between the kernel components. These terminal handlers are also responsible for sending signals to the foreground process, if any. Okay. So these are basically software components establishing some kind of interface between kernel components. Okay. Now signals are just like intimations. Suppose I call you with your name. Okay, I call you like so as a Praveen.
Yes, sir.
Hold on.
Yes, sir.
No, Nitish is not here.
नहीं सर, नीतीश का ये मॉड्यूल है ही नहीं, मैंने उसको 1000 बार बोला है, उसकी मेल भी नहीं है, आप देखो मैंने ऐड की हुई 003 में.
अच्छा.
अब हाँ चेक करो, मैंने अभी भी उसको मैसेज किया, कॉल किया तो उसने उठाया नहीं, मैंने मैसेज किया फिर से. परसों भी मैंने उसको किया था तो कहता मैम आई विल कॉल यू आफ्टर माय सेशन, है ना.
ओके.
मैंने 003 में उसका नाम ही नहीं डाला सर, है ना.
ठीक है.
समझो आप देखो.
So that is how people try to fool us. People are not registered for system programming, they are registered only for C. And they every time since 10 days coming here and attending sessions.
C and C++.
And then when you call them, they are not picking the call. And common man is calling, they're not picking the call, and every time they come to the class and चोरों की तरह class attend करते हैं, है ना? So mark them as poor character people and outrightly ban them from any kind of communication with us forever. Okay. So coming back to this, as I told you, signals. I called you by your name, Praveen. When I called you, did I deliver some message?
No, sir.
No. This is just like signals. You know, signals is a kind of event that will be generated and sent up to the process, just like a nudge, like calling you by your name, or some kind of halting in your normal execution, whatever you're doing. But signals do not deliver any message. It is just like I nudge you and call you, but I don't say anything. That's what the signals do. No message is transferred. Okay. Signals are generated by the shell and terminal handlers to cause interrupts. Signals will be generated by the shell. Also, look at this. There is shell. Inside the kernel, there is something called terminal handlers. Okay. There is something called shell, and there are applications. The signal has to be sent to the application. So the signal has to be sent to the application. Signals are always sent to the application through the terminal handlers. That's fine. But the signals could be generated from the shell also, could be delivered to the application directly, or could be routed through the terminal handlers to be sent to a certain other applications. Signals could also be sent from one application to another application. All these are possibilities with signals. Okay. Yes, Gaurav?
So what are these terminal handlers like? Are they signals?
No.
So
Terminal
some
handlers
specific
are
signals.
software. Terminal handlers are software which are used to send signal to the foreground process. These are just software, nothing other than that. This is part of kernel. Signal handlers are part of kernel. Signals handlers are used by the kernel to notify the foreground process of some event or illegal event, or some event where the application should not proceed further, some event that the kernel did not like, does not want to happen. For all kind of such things, kernel will notify the signal handlers through the signal handler, notify the process. Now,
Signal hand.
who's that?
Excuse me, sir.
Mm-hmm.
Would it be signal handler or terminal handler?
Terminal handlers are the one that generate the signal and send to the foreground process. Okay. Now, why are the signals generated? So signals are generated because sometimes you exceed the resource limit. I mean, you allocate more memory than you are allowed to, or timers expire. Suppose you set a 5-second sleep. After 5 seconds, for that 5 seconds, the process have gone to wait in the wait list for the scheduler. After 5 seconds, when the timer expires, then the process has to be brought out from the wait list to the execution list, and the process starts execution. So timers. Whenever a timer expires, the kernel notifies the foreground process and the scheduler to schedule it for execution, and the process starts to run. Power failure, memory segment violation. That you're familiar with segmentation faults. So all that you get here. Floating point processor errors. So whenever a floating point unit of the processor is being used in some way that is not acceptable, maybe suppose you've given some wrong values. So in that case also, the signals will be generated, and you have some illegal instructions being executed, or the bus not being used properly. Like this, you have many reasons and you have many signals in your system. We use the kill-l system call, which lists all the signals present in your system. There are total 62 signals. Out of 62 signals, first 31 signals are implemented as macros. There is no signal 32 and 33. Signal number 34 to 64 are implemented as kernel sources. This is signal number. Sig hang up, Second, this is your control C that you have been using all these years. SigQuit, illegal instruction, SIGIL. Then any error coming from bus or the kernel want to intervene because the process is using bus in the wrong way. SigBus. This is illegal floating point exception. You want to kill the process. Okay, then segmentation fault. SigPipe. Pipe is being used in the wrong way. Alarm. Okay, then you have SigChild being sent from the child to the parent to notify that the child is over. SigCont. Suppose the process was stopped using SigStop. You can stop the process. And SigCont, continue the stopped process. Signal generated during I/O. SigIO. Wrongly used some system component or system call. SigSys. So these are the signals and many more. Okay, then these are some primary reasons that why the signals are generated. How signals are generated? Well, a signal is an event where it will be some kind of nudge to the process, foreground process, but no message will be delivered. It's an event generated by the Unix and Linux system in response to some condition, illegal condition, upon receipt of which the process may take some action. A signal is a short intimation sent to the process, just an intimation, or could be sent to a group of processes combined at the same time. Every signal will have a number associated with it, 1 to 64, and no data will be delivered along with signals. Now this is the story. You will have, yes सिद्धार्थ,
सर शॉर्ट इंटीमेशन मतलब
मैं आपको अपने नाम से, I call you by your name,
यस सर
to draw your attention, but then I do not deliver any message. That is short intimation. So intimation basically means you are intimating means you're sending some information, some brief information. Okay, but I think that intimation is not going to be the right name here, right word here, because the kernels deliver no message at all. So it is just a nudge. No message is delivered. Okay. Now look at this. Here we have a process executing in the user space, and there are some terminal handlers in the kernel. The terminal handlers will be responsible for generating signals and sending it up to the user space process. Okay, let me pull this image down here to the Jamboard. Now, signals. Are just an event. Event is the right word actually. Generated by terminal handlers inside the kernel and send to the foreground process. No message or data is delivered with signals. Okay. Now, the signals could be generated. There's another term, raise. Signals are raised, and there is another term called catch. These three terms means generate the signal. Signal generation means the terminal handlers just generated the signal, but it is still lying with the kernel. Okay. It has not yet been sent to the process at all. Yes, Siddharth?
सर ये यूजर स्पेस और कर्नल स्पेस क्या है? और एक क्वेश्चन और था कि हमारा प्रोसेस हमेशा कर्नल स्पेस कर्नल के ऊपर नहीं वर्क करता।
पहले मैं पहला सवाल का जवाब देता हूँ। मेमोरी that is available to us for using the whole memory. The whole memory is divided into three sections: user space, kernel space, and IO space. A portion of memory which is in user space, there you execute applications. Like we are using C programs, C++ programs, Python programs, all these programs, everything executes in the user space, and there are processes. That processes get access to limited resources and file system in our computer machine for its execution. On the other hand, kernel space, there you execute the device drivers, the network protocols, and the operating system itself. There is high level of security there. Okay, processes execute this there in a very secure manner. Then IO space, where the memory, where the data transfer happens in block of memory, but blocks of memory, and is used for IO with some alien devices which is outside the system and connected through some ports. So memory is divided into three parts, which I'll explain you later in memory management.
तो सर हमारा जो प्रोसेस है वो खाली यूजर स्पेस में एग्जीक्यूट करेगा।
Yeah, that's right. Okay. Now, signals.
सर एक क्वेश्चन और था सर, डिवाइस ड्राइवर तो एक तरह के प्रोसेस ही हैं सर, प्रोसेस एग्जीक्यूट होते हैं उसमें तो।
Can you repeat that, please?
सर डिवाइस ड्राइवर्स ये सब भी तो एक तरह का प्रोसेस ही एग्जीक्यूट करते हैं।
Device driver is not a process. Device driver is a part of kernel. Processes are some things that execute in user space only. You know, the device driver doesn't execute in user space; it executes in kernel space, and there is no concept of processes in kernel space.
सर प्रोसेस हमारा कोड ऑफ सेगमेंट ही तो जो हमारा एग्जीक्यूट हो रहा है किसी टास्क को परफॉर्म।
What is the term code of segment?
सर जिसमें सर बंच ऑफ हमारा कोड के प्रोसेस।
Code segment.
यस सर।
The code segment is part of the process context. It contains stack segment, extra segment, library segment. It contains data segment, heap, file descriptors. You can't say that the code segment is a process as a whole.
No, sir. He is saying the bunch of code is written in a file. That code. That tiny code.
Can you repeat that, Siddharth? फिर से बोलो।
सर जैसे हम कोई भी फाइल बनाते हैं हम प्रोग्रामिंग की, उसे किसी पर्पस के लिए बना रहे हैं, कोई टास्क एग्जीक्यूट करने के लिए, तो एक प्रोसेस ही तो एग्जीक्यूट कर रही है सर।
File, the term file means it is stored in the secondary storage, not in memory. The term file means it is some kind of hardware, certainly not in memory. So maybe that file contains your compiled code, the file name is a.out, you have just compiled it. That's fine, but it's kept in secondary storage, it's a file, it is not a process. When you will execute it by the loader loading it into the memory from secondary storage, it will come in memory, it will expand in memory, occupy space, and that occupied space will be called process context, and that it will be allocated with the processor for the first time. Then onwards it will be called process context. Process. There is a difference between the term process and program. Program is something written and stored in a file which is in the secondary storage, whereas process is an active, alive, running code in memory allocated with the processor. You understand the difference between program and process? Program is a file. Process is active, alive, running program. Now ask your question again. Siddharth.
तो सर कर्नल के जो प्रोग्राम्स रन हो रहे होंगे जो एक्टिव प्रोसेस कहेंगे उसे.
Well, all the programs that are executing could be active processes. Could be process. But if something is not executing, it's not a process. It could be file, or maybe file containing programs. So it could be a program, but certainly not a process.
Actually, sir, our kernel is also a type of program, no sir?
No. When we talk about program, it's a code, it's a program, but not a process.
So sir, if that program runs in a kernel space, then how we can differentiate between the user program or kernel program?
Well, it's a very good question, but right now I would say only one thing, that the kernel does not execute as a program, as a process. Okay. How kernel executes? The kernel has its own context that I'll explain to you when we'll go there, reach there. But yes, everything that is executing in the user space is executing as a process which has a process context. Kernel has no process context as such. Kernel has its own kernel context and executes in a very different way that we have not discussed, I think, till now. Because we have not discussed anything, that it is obvious for you to think that okay, kernel is also one of the many programs. It doesn't execute like that. Kernel is also one of the many processes. No, that's not the right. So coming back to this file, here you see this. We have a terminal handler. Okay. From where the kernel signals was generated, but is still not sent up to the process. Generated, but still not sent up to the process.